this video, we'll explain why the normal random variable appears a lot in the real world. And the answer is the central limit theorem. And so what the central limit theorem says, if you add up many, let's say 30 or more, independent random variables, in other words, the random variables, excuse me, have no effect on each other, the sum will be normal even if the individual random variables are not normal. Okay, and what that means is if you're adding up a bunch of random variables and you want to know the distribution, you only need to know the mean and the standard deviation. Now, some results that will be helpful to us, the mean of this, or the expected value, whatever you want to call it, expected value of the, let's call random variables x1 through xn. The expected value of the sum is just the sum of the expected values. So if you add up n random variables, you want to know on the average what you're going to get, just add up, let's use E, expected value of x1, plus expected value of x2, plus expected value of xn. Now, if the random variables are independent, and we require this for the following formula, the expected value formula does not require independence, or independent, then the variance of the sum of n random variables is the sum of the variance. You would add up the variance of each one. So the variance is add, but since the standard deviation is the square root of the variance, that's always true, the standard deviations don't add. So if you add up 100 random variables with the same variance, the variance of the sum is 100 times the variance of 1. But the standard deviation would only be 10 times the standard deviation of 1. Okay, so let's illustrate how we can use the central limit theorem, okay, to estimate the following probability in an interesting situation. So we have 400 customers at our supermarket, and they'll buy either 0, 1, or 2 chocolate bars. There's a 50% chance each customer buys 0 chocolate bars, a 40% chance each customer buys 1 chocolate bar, and a 10% chance each customer buys 2 chocolate bars. So the number of chocolate bars each customer buys is certainly not normal. It's discrete. But if we add up the total bought by the 400 customers, it's going to have a histogram like this. We can show you using great add-in for Excel called that risk that plays out a situation many times. And if you look at the sort of the probability density function of the number of chocolate bars that will be bought by 400 customers, it's going to look a lot like a bell curve. Okay, so and you can show that if you play this out a couple of thousand times, the chance of selling at least 260 chocolate bars is around 5.9%. Now, don't be alarmed if you don't have that risk, which you probably don't. Then you're going to get error messages in these cells, but that's not really important. Okay? But what I want to show you is if I use the central limit theorem, because adding up 400 independent random variables, the number of chocolate bars one person buys doesn't affect the other person, I don't think. If we add up those 400 random variables for how many chocolate bars each person buys, and we find the mean and standard deviation of the sum using the formulas over here, then we can use the normal function to figure out the chance we sell at least 260 chocolate bars. So what's the mean number sold of 1 chocolate bar by one customer? Sold chocolate bars bought by one customer. Take the values and multiply by the probabilities. So on the average, we're going to sell 0.6 chocolate bars. There's 400 customers, and so we expect to sell about 240 chocolate bars would be the mean. Now, to find the variance for one customer and the standard deviation, remember we take the expected value of the squared deviation from the mean. there's that minus this. So the variance for one person would be take the expected value of that square deviation column so you take the probabilities and weight the square deviations by the probability. So that's sum of product function. Okay, so the standard deviation for one customer, the number of chocolate bars they buy, is the square root of that. Not that we really need that in this case, you'll see. Okay, so what's the mean? So the total chocolate bars bought by 400 people. The mean would be just the mean of what the first person buys plus the second person plus the 400th person, and that's just 400 times 0.6. Now, what's the variance? Remember, the variance of the sum is the sum of the variances. So I take the variance of the first customer's purchases, 0.44, and there's 400 customers, so I get this. And the standard deviation would be the square root of that, which is about 13 or so. All right, so the chance that more than at least 260 chocolate bars are bought is 1 minus, I should say, the chance of 259.5 or greater, because 259.5 would round to 260. So I'd say norm dist 259.5. I've got a mean of 240 and a standard deviation of 13.2665, and I need the word true there. So that's chance of selling 259.5 or more chocolate bars. I got 7% instead of 6%, which is pretty close. To show you how I estimated that probability, let's run this at that limit. We'll save this here. Don't want anything to crash. Okay, so if I would run this, let's say 1,000 times, 5,000 is pretty slow. All I have to do is tell this great add-in at risk by Palisade Corporation. Go to palisade.com if you want. Okay, I can run this 1,000 times. And it should run pretty quickly. Taking a bit of time here, but what it's doing is having each customer being played out with a 50% chance of buying none, a 40% chance of buying one, and a 10% chance of buying 2 chocolate bars. Okay, here it's making a leap of faith, and we're pretty much done there. Okay. So then I can get a graph here, and I could say the chance of 260 chocolate bars or more, I get 6.1% this time. Excuse me, but our approximation is pretty good. I mean, I got 7% rather than 6%, and that's very, very close. But the key thing to remember is if you add up 30 or more independent random variables, the sum will be normal, even if the individual random variables are not normal. So for example, in an NBA game, the number of points a team scores. On a given possession, they'll usually score 0, 1, 2, or 3 points. That's not normal, but they have maybe 100 possessions in a game, so the total points they score will generally follow a normal random variable. Okay, well that concludes our videos for the present time on random variables. There's some more advanced random variables that we may cover and do some videos on in the future, but I haven't decided.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.